singular matrix is a square matrix that doesn't reduce to the identity. Okay? So, among other things, you've got a singular matrix, it's not invertible. Okay? If A is singular, doesn't have a unique solution. Okay? Maybe it has multiple solutions. It doesn't have a unique solution. It can't solve the equation. Maybe it has no solution at all. Okay? You can figure out which. Probably ask you to think about that. Okay? That's another terminology that you just want to be familiar with and comfortable with. Okay. Well, I'm tempted to tell you what an elementary matrix is, not do anything with them. An elementary matrix is just a matrix you get from the identity by doing one of your row operations. Okay? So let's just do that much to get the terminology, because it's very simple. Now what you do with them isn't all that simple. It immediately leads you to LU decomposition and stuff, which is kind of the first big idea. Okay. Elementary, yeah, okay, elementary. I left out the M. Matrices. Just this. Okay? And just to see a couple of them, just a 2 by 2. Anything higher. One, 0, 0, 1, if you multiply the first row by 6, gives you this elementary matrix. Okay? Or it can go to 0, 1, 1, 0 by exchanging 2 rows. Okay? Or it could go to this by adding 5 times the first row to the second. Those are all the operations you can do. I mean, you can add a multiple to the second row to the first as well, you know. But multiply a row by a number, interchange 2 rows, add a multiple of a row to another. That's it. Those are the only operations you've used. Those are the only operations you need. matrix is invertible, if it's non-singular, you can invert it and the process will work. I haven't proven that, but it's pretty plausible. Okay? Makes sense? That's it, that's the definition. Now, we do a lot with them, but I'm not going to talk about that today. Just tell you what they are. From the identity, implicitly, from the identity, you'd have to do this, and then you'd have to do this. Okay? And just a little note to tease you a little bit, to tempt you a little bit. Think about it. If I multiply the matrix, it adds 5 times the first row to the second by the matrix. This matrix inverts the rows. Multiply the row inverting matrix by this, I invert the rows. Okay? If I multiply this matrix by any other matrix, I end up with a matrix I would get if I added 5 times the first row to the second. Okay? So these elementary matrices do those sorts of things. But we'll do a little bit more with that next time. Or maybe, put a little something in homework to at least demonstrate, if not prove. It's pretty easy to see why they work after you multiply a couple of them. Okay? That's elementary matrices.
All right.
We're going to do good things with them.
Okay.
You're going to like it.